What's up YouTubers, Jose Quiñones the CNC Dude here. Hey, in the past few videos I've been talking about three-phase BLDC motors, and today I want to start talking about the electronics. I have recently joined the Hackaday IO Challenge, which is basically a competition where we're asked to design a module that can be used to drive a robot. And since robot has plenty of motors, I believe these modules could be a good example of something that could be used for that purpose. So let's take a look at the modules that I have been designing for the past few years and how we use them to drive three-phase BLDC motors. Alright, so what I have here is a module that I call a PowerPACK. And the reason why I call it a PowerPACK is because it's made of two boards. Okay, these two boards, they plug in like this. And now you get all of the power required to drive your three-phase BLDC motor. The two boards, I call them the brain board because this is where the microcontroller is, and this is the FET board or the switch board because this is where the FETs, which are going to be doing all of the legwork in terms of driving current and applying voltages. That's the guy doing that, and together they form a pack. A power pack. But the funny part is that it is a pack as in PACK, also because it has a device that is called the PAC52xx, but in this case it's PAC for Power Application Controller. So this is the chip that I work with. That little guy, okay, this little guy has everything that you need to drive your three-phase BLDC motor. Everything except a few passives, of course, that are required, you know, for decoupling, filtering, stuff like that. Some components for doing the buck converter, which is basically how we step down the voltage from the power supply or your battery. And of course, the power FETs. And the reason why you cannot put the power FETs inside of the component is because we're dealing here with ridiculous amounts of current. I mean, in some cases it could be hundreds of amps. There is no way to put that kind of power component inside of such a small device. Believe me, today, 2018, there is just no way to do it. Maybe in 100 years we can do it, but today we have all of the pre-drive stage, analog circuitry, digital circuitry, microcontroller in here, and then the power stage in here. So together they become a pack, and this is what I call a power pack. Now you must be asking, wow, why make it on two boards and not one? Well, you can do it on one as well. Here's an example of one board. This I designed for Powell Tool, so it's called Tulio, but it's a power pack. And here's the same chip, PAC52xx. Let me make it bigger. Notice how tiny this guy is. It's tiny. And then here are the power FETs. And this is the sense resistor. The sense resistor is what we use to read what is the motor current, and then we regulate motor speed with that. We use it for regulating current, and then we use it also to command for the speed. This is a small LDO here. It's what we use for stepping down the voltage. This is basically a 20-volt board, okay, 20 volts, whereas this guy is up to 70 volts, and that allows me to do this. That is my motor here. It's a drum motor, but you know, pretty much any three-phase BLDC motor can be driven. Right now I am operating in sensorless mode, so that means that there are no Hall sensors. A lot of wind here. I exceeded my limit there. Basically the power supply, let's see if I increase the voltage. So right now I'm using this board that has a buck converter, so I can put up to 70 volts, but let's see what happens with 26. Hertz, 26 volts, 2.5 amps. And that's an example of what you can do to drive your motor. Now this is basically as it was. We were driving maybe what, 75, 80 watts, not a ridiculous amount. With a board like this, you might be able to do 300 watts without much of a hassle. If you want higher power, this is my higher power version of this system. Now this uses a 5223. And this guy uses a 5232, which is a different device, but you know, the code is the same. It's not identical, but it's very similar. And you can do pretty much the exact same thing, but this guy goes up to 160 volts. So that gives you far much more power. You can see I have here my TO247 FETs. And big aluminum pieces, and you know, this is an experiment. I have not come to the point of doing all of the required tests to validate that this is gonna work. I mean, ideally you would have made these metal slugs out of copper. So I don't know how this is gonna work. I'm still this is on the infant stage, but the concept is that this guy would be able to drive maybe 1,000 watts, maybe 1,500 watts. I don't know yet, but you know, if you have a 60 volt battery at 10 to 20 amps, now we're talking 600 to 1200 watts. That's the premise. So we'll see how that goes. But you know, it's the exact same design over and over, but it's scalable. You can use it for driving small motor, medium motors, big motors. And there is a version which I haven't made a module for that can go up to 600 volts. So that tells you the amount of power that we can deal with. Alright, so this has been a good introduction to the PowerPACks using the PAC52 family of devices, the power application controller, and how we can use this platform to drive your 3-phase BLDC motor. Have a good one!